This is a short video presentation of my prototype intrusion detection system using deep neural networks for my final year thesis at UTS under the supervision of Hong Dim. This article defines a model of intrusion detection using deep neural networks consisting of hidden layers of GRBM and RBM, deep learning layers. This model takes feature sets such as the NSL KDD and trains the neural network model, being able to output if network traffic is normal traffic or a classified attack, such as a denial of service. The system we're going to present is a proof of concept solution using this deep neural network model, which detects and alerts on network traffic attacks in a real world and live scenario. This is a high-level architecture overview of the environment that has been built. This consists of 6 key modules. The first is the web server, which hosts the target website and its databases. The second is an inline network feature extractor or probe, which is responsible of extracting network features from the relevant network traffic. The next is the content feature extractor and dataset compiler, which extracts relevant features from the website's database and compiles it with the network traffic into a single dataset. The next is the neural network trained model, which is a trained model consisting of the environment's baseline and using Professor Nguyen's framework. Lastly is the prediction module, which is responsible of taking the features compiled from the web server and passing it through the trained neural network and outputting the prediction if the session is an attack or not. An example of this is, say a user is requesting a website on the web server. The request data is passed through the network feature extractor, as well as data stored on the website's database. The content feature extractor and dataset compiler takes the data from these two sources, compiles it into a single dataset. This dataset is then passed to the prediction module, which then passes it through the trained neural network and then provides an output if the prediction module thinks this is an attack or not. The proof of concept environment we're about to demonstrate has been built on this infrastructure. This infrastructure consists of a Core i7 CPU server with 32 gigs of RAM and an NVIDIA video card running Windows 10 operating system with Hyper-V enabled. The training and prediction module run directly on the base operating system and utilizes the machine learning ready video card. The hypervisor platform runs 2 VMs. One is an attack VM running Kali Linux. The second is a web server VM running Apache, as well as MySQL, and also the extraction and compiler modules. We will now jump into the demonstration. Here we have our trained neural network model, which has been trained for approximately 3.5 hours and has achieved an accuracy of 97.7% during its training. The data that was used as part of this training came from the NSL KDD training and testing datasets, which are available online, as well as data that was extracted from our environment, as explained in the documentation. This dataset contains a total of, going through the history, a total of 200,000 DOS attacks, 70,000 normal, as well as various other attack numbers for training and testing, and has got a total of 41 features, which is defined in the NSL KDD documentation. Now let's look at the feature extractor and compiler module which are running on the web server. This module is running as a combined script which is executed in a loop. The feature extractor is run as 20-second intervals on the web server, capturing all network data. This data is then passed into various modules which combine the data using the data extracted from the database into the relevant 41 features required for the prediction module. This is then sent from this system to the prediction module system via SFTP, dropping the file with a flag advising the prediction module that the data is now available to be predicted on. Let's now run this as a test, logging in as a normal user. Here we have the login page, which is hosted on the web server. As you can see, this is a very simple login website with just a username and password field. Authenticating as a normal user, the system has now captured the relevant network data for a successful login user. Once the extractor has finished its loop, it will pass this data to the prediction module, and the prediction module should predict a valid logon with the value 1. You can see this has now predicted a successful login and has advised that the connection is an allowed user connection. Now let's run some network attacks against a web server and test our intrusion detection system. Here we have an attacker's machine running Kali Linux, which has some preloaded network attacks that will run against our website to test our intrusion detection system. We'll first start off with a denial of service attack, which does a simple sync flood using the tool hping. We'll run this for a few seconds, and this should output over here zeros, which should indicate a denial of service attack. As you can see, the capture has got too many packets to display in the console session. So let's look at the backend output file. Here you can see that it has successfully identified denial of service attacks due to the value 0. Now let's go run a port scan attack. A port scan attack should return the value 2, identifying that we are doing a probing attack against the web server. Let's look at the output file once again. As you can see, it has successfully identified probing attack due to the output value 2. Lastly, let's run a brute force attack, which should simulate a user to root network attack. As you can see, the system has successfully identified value 3, which means it has picked up a brute force attack. I hope you enjoyed this short presentation on my intrusion detection system using deep neural networks. For more details, please refer to my thesis documentation.